This is section 10.3 in your textbook on what are called complex fractions, which sound really bad, but you've actually seen them before. So a complex fraction is a fraction divided by another fraction vertically. Normally we see one fraction and see the division bar, and then we see a different fraction. Here we're seeing the same thing, it's just vertically aligned instead of horizontally aligned. So to simplify these, we flip the second fraction, which would be the bottom fraction, and we multiply. So here we have one fraction here and a separate one here. So we're going to take the bottom fraction, we're going to flip it upside down, and we're going to change it to multiplication. So it's going to be 9 over 6x squared. So from there, you multiply the top times the top and the bottom times the bottom. That's going to give us 18 over 27 times 6, which is 162. And we have x squared and y squared. So it'll just be x squared, y squared. And then we'll see if we can reduce 18 over 162. If you type that in your calculator, it will give you a decimal. Then if you hit math and fraction and hit enter twice, it will give you your fraction in lowest terms, which really makes it nice. So that's going to be 1 over 9 x squared, y squared. So you reduce if you can. So it's really not as bad as it looks. They look much worse than they are. Same idea on example 2. We have the top and the bottom fraction. We're going to flip the bottom fraction and multiply and make it x minus 2 over 10. We have x minus 2 on the first fractions on the denominator, and since we flipped, the second x minus 2 becomes a numerator, so we can cancel or divide those off. And that leaves us 5x over 10, which reduces to just x over 2. So these really, like I said, they're not as bad as they look. They can get worse, of course. So if the top or bottom has more than one term, which is often the case, you add or subtract first. You want to combine to get one top and one bottom, and then flip and multiply. So example 3 looks so much worse. And that's because instead of having one term, like examples 1 and 2 did, it has 2 terms on top and 2 terms on the bottom. So what we're going to do is focus all of our attention just on the top and get like common denominators. So we have y squared and y, which means, and you might want to do this in a different color, you need to multiply that second fraction by y over y, which gives us x plus, and then 1 times y is y, over our new common denominator, y squared. So we make a common denominator, put the tops together, and have our common bottom. That combines those two fractions. And then divided by, same idea on the bottom, we have x squared and x. So we're going to need to multiply the second piece of the bottom by x over x. And that's going to give us y plus x over x squared. So now we have one piece on top and one piece on the bottom. So now we can flip and multiply. The x squared will go on top, the y plus x will go on the bottom. And let's see what we've got now. So now we have x plus y on top and y plus x on the bottom. Even though they're switched around, they're all positive, and for addition it's okay if they're switched. So those actually divide off. Should be x squared for a final answer of x squared over y squared. So it looks a little bad at first. You have to make those common denominators, and then it's not so bad. Example 4 and 5 have an integer piece and a fraction piece, and so we want to make sure we are careful with that. So what we really have is 5 over 1 minus 3 over x, all divided by x over 1 plus 2 over x. Remember, when you have an integer, you just put it over 1. So we're going to use the same technique as example 3. We're going to look at the denominators of the top. We have 1 and x, so we need to multiply this one by x. And that's going to give us 5x minus 3 all over x. And we're going to do the same idea on the bottom. We have 1 and x, so we're going to multiply this one by x. That's going to give us x times x, which is x squared plus 2 over the common denominator x. When you have binomials, it helps to put parentheses, like I always say that no matter what you're working on, so that when you flip, it's a little easier to see. So now you have x over x squared plus 2. You can see that you have an x on the bottom, x on the top, all by itself, so those can divide off. That gives us a final answer. We can put that together. 5x minus 3 over x squared plus 2. And that will be your final answer. Go ahead and try example 5 on your own. I would pause the video, see if you can work out example 5. It's similar to example 4, and just kind of see how far you get, and then play the video to check your work. So I'm going to write this as 5 over 1 minus 2 over x over 1 plus 2 over 3x. Then I'll work on getting my common denominators. So we need to multiply this one by x over x. That's going to give me 5x minus 2 all divided by x. For the top. So I like to work across on these so I don't lose my pieces. It's easy to get these all mixed up. I'm going to multiply the bottom by 3x, and that's going to give me 3x squared plus 2 all over 3x. I'm going to take that bottom piece, flip it, and multiply. Put that in parentheses so I can watch my work. That's 3x over 3x squared plus 2. The only thing that divides off on this one are the x's. So my final answer, I'm going to move this 3 to the front because we like to put coefficients first. It's going to be 3 times 5x minus 2 over 3x squared plus 2. And remember, that's stuck together, so don't divide off those 3's, even though it's very tempting. So that will be my final answer on example 5. So it's a little tedious at the beginning. Different colors can help so you can really see what you're doing, but as long as you flip and multiply, there's really not much to it. Of course, it can get a little messier. Example 6 has got a lot going on. And I know the font came out a little small. I tried to make it bigger, but it still came out pretty small. So you have x minus 1 over x minus negative 4 over x minus 1. This minus and negative, we can just go right ahead and change that to addition. I'm going to rewrite it a little bit bigger so we can really see it. We have x minus 1 over x. It's going to become plus positive 4 over x minus 1. So one of the denominators is x, the other denominator is x minus 1 for the top. So this one's a little bit more involved. We're going to have to multiply the first part of that one by x minus 1. And the second part of that one's going to have to multiply by x. Because the denominator needs an x all by itself and an x minus 1. Here we're going to have to FOIL, which again kind of sneaks in sometimes. So anytime you have a binomial and a binomial, FOIL parentheses are again very helpful to see that. So we're going to get x squared minus 2x plus 1 plus 4x on top, and then x times x minus 1 on the bottom. That's just the top half of this fraction. So like I said, it gets very involved very quickly. Let's look at the bottom. So we have x and x minus 1 again. So we're going to have to multiply the first part of this one by x minus 1, and the second part of this one by x. And you can write it again if that's too small for you. You can write it under here. Either way is fine. We're going to have to FOIL this one. That should give us x squared minus 1 plus, we're going to distribute that, x squared plus x. So, and then over x times x minus 1. So I'm going to clean this one up. You're going to get 2x squared plus x minus 1 over x times x minus 1. We can also go ahead and clean up this numerator, put those two together. Alright, from here, and again, color is so helpful in these because it just looks like a bunch of terms all jumbled together. You're going to take this fraction, you're going to flip it and multiply it. I'm also going to combine those terms. So let me show you what we get from there. We're going to have x squared plus 2x plus 1 over x times x minus 1 times, flipping this one, x over x minus 1 over 2x squared plus x minus 1. Whew, so much going on there. From here, the x's can divide off, the x minus 1's can divide off. You're left with x squared plus 2x plus 1 over 2x squared plus x minus 1. Most of the time you're just finished, but these can both factor. So if we factor these, the top becomes x plus 1 times x plus 1. And the bottom becomes 2x, let's see, minus 1 times x plus 1. Again, make sure you can factor that on your own. Which means that some of this can divide off. And we finally get down to an answer of x plus 1 over 2x minus 1. So that one had a lot of little intricacies. Had to watch your signs, you had to multiply, FOIL some stuff together. We got it down to 2 trinomials, and sure enough they both factored, which made another piece of it divide off. So you really want to get it down as simplified as you can. Let's go ahead and try example 7 on your own. There is subtraction in it, so you really want to be careful. I would pause the video here and try example 7 and then play it back. Let me see if it'll let me zoom in. There we go. Zoomed in a little bit there so you can really see it. So pause the video, try example 7, and then play it back and see how you did. Alright, so looking at example 7 from the very beginning, we want to go ahead and make common denominators at the top. So that'd be multiplying by x minus 1. And on the other side we'll need to multiply by x. Careful here because it is subtraction. And so we're going to have to FOIL these two binomials to get x squared plus x minus 2, and then minus 2x from this part over x times x minus 1 for the top. For the bottom, we're going to have to do the similar procedure. I'm going to have to multiply this by x minus 1. And I need to multiply this by x, which is going to give me, I'm going to have to FOIL these. That's going to give me x squared minus 1 plus x squared plus x over x times x minus 1. So kind of keep your main division bar as lined up as you can. I know it's tough, but try to keep that main division bar really separating the two. So cleaning the top of the first one up, put those two guys together. That's going to give me x squared minus x minus 2 over x times x minus 1. And again, there's the main division bar. If I clean this one up as well, it's going to give me 2x squared plus x minus 1 over x times x minus 1. So clean them up, try to keep everything top and bottom nice and organized. Then when it's all ready to go, you take the entire bottom and you flip it and change it to multiplication. So coming down here, that's going to give me x squared minus x minus 2 over x times x minus 1 times x minus 1 over 2x squared plus x minus 1. I know that's a mouthful. Hopefully you can see all of that more than hear me say it all. And then the x's divide off, the x minus 1's divide off. Let's factor our trinomials. So always factor if you can. That's going to factor into x minus 2 and x plus 1. It's going to factor into 2x, let's see, minus 1 and x plus 1. So I'm going to write it in factored form, x minus 2 over times x plus 1 over the factored form of the bottom, 2x minus 1 times x plus 1. So that's a lot of work. Got them factored. These guys divide off for a final answer of x minus 2 over 2x minus 1. Now, they might not get quite that complicated in the homework and exam. It's just they can, and it is an awful lot of work, and you really have to keep straight where that main division bar is, a highlighter or marker to mark that main split, and kind of keep everything working, just the top, just the bottom. Really keep up with where you are in each part of the process. And that's it for complex fractions.